welcome back. Today we're going to talk about derivative of trigonometric function. Before we get into it, let's mention this specific identity. Consider the limit sine theta divided by theta as theta approaching to 0. This limit is 1. Instead of theta, you could have x, h, doesn't really matter if this variable was h. You still have the same result. If it is x, doesn't really matter. So the limit sine x divided by x is equal to 1 as x approaches to 0. There is a geometric way to prove this. I don't want to get into it, but it's available in the book. But I want to give you an idea of what this really means. It means that if you consider the graph of sine functions, so sine looks like that at the beginning, and it goes down after, and so on. And compare it with the graph of y equal to x. The graph of y equal to x. And this is y equal to sine x. If you compare these two curves, around 0, the behavior of sine and y equal to x are the same thing. That means the ratio of sine x to x around 0 is basically 1. So this is what it means, is that they behave almost the same around 0. Okay. Again, you can see the proof in the textbook. Is a geometric. It's basically a squeeze theorem. They will show that cosine x is less than sine x divided by x less than 1. And you say now as x approaches to 0, what happens is left side becomes 1. Cosine of 0 is 1. Right side is 1. So what you get is the only possible way that sine x divided by x is between 1 and 1 is that if this limit equals to 1. This is the idea for the proof. Since the subject for this section is derivative of trigonometric function, I don't really need to get into the geometric part. I just wanted to mention it. So let's figure out what is the derivative of sine function. So here, let's start with, sorry, 1 second. Let's start with the derivative of the sine function. Sine x equal, the derivative of sine is given equal to cosine x. Okay, so how do you prove the derivative for sine function? What we need to do is similar to what we've done for finding the slope of the tangent line. You first figure out the f of x plus h, then subtract it from f of x, figure out what is the limit as h approaches to 0. So here I'm going to assume that f of x is given sine x. Figure out what is f of x plus h, which would be sine x plus h. And there is an identity for sine x plus h in trigonometry. You have probably seen it. It's sine x cosine h plus sine h cosine x. You might not have seen it as x and h. You might have seen it as alpha and beta. This was the identity. Sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. It's not necessary to memorize any of these identities. You should know the derivatives as well as this limit, but the trigonometric identity is not necessary to remember. Okay, so here, what we want to calculate is f prime. So what would be f prime? F prime would be limit f of x plus h, which is sine x plus sine x cosine h plus sine h cosine x, and minus the f of x. F of x is simply sine x. All divided by h as h approaches to 0. We want to calculate this limit. Okay, there are two terms that contain sine x. I'm going to write those two terms together. So limit sine h cosine x divided by h as h approaches to 0. I pick this term by itself. The other two terms contain sine x. These two contain sine x. So I'm going to write them as plus limit h approaches to 0, sine x, and here, number 1 and number 3, these two, they both have a sine x in common, so I factor out the sine x. What is left from the first one is cosine h, and from the second term is just -1. Divide by h. It's the same fraction, I just split it for the simple reason that I want to use the identity that we talked about. The identity that we had is limit sine x divided by x as x approaches to 0. Again, make sure that x is approaching to 0. If this happens, what do you get as the limit is 1. So if I look at this limit, I have limit h approaches to 0, sine h divided by h. Ignore the cosine for a moment. Cosine does not depend on h, cosine of x. So this part, I can say simply that becomes 1. So what do I have is 1 times cosine x. So this is simply 1 times cosine x. Plus, now the other limit. The other limit is limit sine x times cosine h minus 1 divided by h. If you replace h with 0, you get 0 over 0. So the trick here is that I want to multiply this by cosine h plus 1 and cosine h plus 1, both in the numerator and denominator. This is just to interchange the cosine into sine by using a specific identity. So what do I have? There is still 1 times cosine x is cosine x, still there, plus this sine x does not really depend on the limit. The limit is for h. So I can write it outside, sine x times the limit cosine h minus 1 times cosine h plus 1. So if I multiply the numerators, I times that, times this, -1 times that, -1 times +1. What do you get is at the end cosine squared h minus 1. Divide by denominator is h times cosine h plus 1. I'm skipping some of the steps, but I don't think it's that complicated to do the distribution. Okay, why did we do all this? There was an identity for the sine and cosine. If you remember, sine squared x plus cosine squared x, this summation is always 1. So what is 1 minus cosine squared would be sine squared. So therefore, cosine squared minus 1 is simply sine squared h, but the negative. You can calculate through here, replace x with h. Move the sine squared h to the other side and subtract 1 from the right side as well. What you get is cosine squared h minus 1 equals negative sine squared h. So all this was to get to this point of cosine x plus sine x times limit sine h, sine squared negative, divided by h times cosine h plus 1 as h approaches to 0. Again, now instead of writing negative sine squared h, I'm going to write it as negative sine h times sine h. So you can see this part again. The identity that we used, sine h divided by h as limit h approaches to 0. What happens to this part? This is simply becomes 1. So what do you get is cosine x plus sine x. This part is simply 1. So what do we have left is times limit h approaches to 0, negative sine h is left in the numerator, and divide by cosine h plus 1. Now if you replace h with 0, what do you get is cosine x plus sine x times limit sine 0 is 0, divide by cosine 0 is 1, 1 plus 1 you get 2. So what do you get? Cosine plus sine times 0 over 2. This 0 times whatever, this term is disappear. So what do we get as the derivative? Is that derivative is cosine x. This proof is not necessary to know, but it's good to see the proof so that you know that nobody just came up with this without any reasoning. There is a reason behind it, and it's exactly going through the process of the derivative. Okay, so what we can say is if sine is given and they ask you for the derivative is cosine x. Similarly, you can prove that if they ask for the cosine x derivative, derivative is negative sine x. You can go through through a similar process and show the derivative of cosine is simply negative sine x. How about the derivative of tangent? Derivative of cotangent, derivative of secant and cosecant. These are consequences of sine and cosine because tangent is simply sine x over cosine x. So you can use the quotient rule and say derivative of numerator times denominator minus, so here I'm going to do that for tangent, so you see that the derivative of tangent, find the derivative of tangent. Tangent x derivative would be saying tangent is sine x divided by cosine x. And if you want to find the derivative, you can use the quotient rule. Quotient rule was the derivative of the numerator multiplied by the denominator without the derivative minus the numerator times the denominator derivative, all divided by the denominator squared, cosine x squared. Okay, what's the derivative of sine? We already figured out the derivative of sine. The derivative of sine is simply cosine. What's the derivative of cosine? Count this as well, negative sine x. So what do we have is cosine times cosine, cosine squared x. Negative sine times negative sine, it becomes plus sine squared x. All divided by cosine squared x. And what is this? Cosine squared plus sine squared. Remember the identity, 1 divided by cosine squared x. So what is 1 divided by cosine squared x? Secant x is 1 divided by cosine x by definition. So what would be secant squared x? It would be 1 divided by cosine squared. So here are the other identities. Tangent derivative, we proved it just now. The derivative is secant squared x. Cotangent derivative is negative cosecant squared x. Again, you can go through the quotient rule and prove all these. Secant derivative, I recommend you go through this. Derivative of secant x derivative. This is secant x times tangent x. This notations, I just want to introduce the prime notation as well. Cosecant derivative is negative cosecant x and times cotangent. There would be similarity if you know how to do derivative of tangent. Similarly, derivative of cotangent is possible. Derivative of secant is given. Derivative of cosecant is very similar. Okay. So these 6 identities, these derivatives that you should know. You should know these 6 derivatives. If you know the first 2, you can compute the other ones as well. Okay. So let's assume we know those derivatives. Let's calculate the f prime. So here, as an example, find f prime x in all these cases. Okay. So f of x is given x squared times sine x. What would be f prime? We have 2 functions multiplied by each other, x squared sine x. You have to use product rule. Do not write 2x times the derivative of sine x. That's not correct. You have to write the product rule. Product rule says the derivative of the first one times the second plus the first function times the derivative of the second. Okay, derivative of x squared, drag down the exponent, subtract 1 from the exponent. You can use the power rule. You should be an expert by now from that. Derivative of x squared is simply 2x times sine x plus x squared is still there. Derivative of sine x, you just learned it. It's cosine x. This is the derivative. No need for simplifying, that's good enough. How about the next one? Sine x times cosine x. What would be f prime x? Again, you have 2 functions multiplied by each other. You should use product rule. You should say derivative of the first one times the second. Write this. Bit better, sine x derivative times cosine x plus sine x times derivative of cosine x. Derivative of sine x is cosine x times cosine x. And the derivative of cosine is negative sine x. So you get plus sine x times negative sine x. If there is a negative sign, always use parentheses because there is a multiplication. You have to be careful. So what you get is cosine x times cosine x is cosine squared x. It's not x squared. Do not multiply the x's. Cosine x squared. You can write it this way. You can write it like that. But normally they write it as cosine squared x. It's the same meaning that you have cosine x times cosine x. Plus sine x times negative sine x is negative sine squared x. If you're typing your homework, I recommend you do this instead of writing it as cosine squared. So maybe I should stick with this format. Cosine x squared minus sine x squared. That would be the derivative. How about derivative of sine x divided by 1 plus cosine x? This is a fraction. You should use the quotient rule. So f prime x would be, try the quotient rule. Derivative of the numerator, sine x. Do this step always. Write this. What is the quotient rule? It's the derivative of the numerator times the denominator. 1 plus cosine x. And minus the numerator, which is sine x, times the derivative of the denominator. 1 plus cosine x derivative. All divided by the denominator square. 1 plus cosine x squared. You do not need to calculate this denominator square. Just leave it as it is. You need to figure out what are these two derivatives. This is the question. If you figure out these two, then you can simply distribute the numerator and simplify if you want. Derivative of sine x is cosine x. So I have cosine x times 1 plus cosine x minus sine x. Derivative of 1 is 0. Derivative of cosine x is negative sine x times negative sine x. And again, I mentioned that if you use multiplication, make sure that next to negative there is a parenthesis. Otherwise, you're subtracting. You say negative sine x minus sine x. And finally, you can say cosine times 1 is cosine. So you will get cosine x plus cosine x squared, cosine times cosine. And negative sine times negative sine is positive sine squared x. All divided by 1 plus cosine x squared. Okay, what is cosine squared x plus sine squared x? This thing in the numerator. You don't need to simplify, but there is a identity. Cosine squared plus 1, sine squared is simply 1. So you have 1 plus cosine x in the numerator. The denominator is 1 plus cosine x squared. You should see that you can simplify this. You can cancel out one of the cosines, 1 plus cosines in the numerator and 1 in the denominator. So you get 1 plus cosine x. You can cancel out this guy. Okay, so this is the derivative of sine x divided by 1 plus cosine x. How about if I have 3 functions multiplied by each other? What would be the difference? Let me choose a different color. Okay, so now what you have is 3 functions multiplied by each other. But we didn't learn product rule for 3. What we learned was product rule only for 2. So what I'm going to do is I'm going to consider these two as a one function, and x squared is another function. What do I have is x squared times another one. I'm going to write product rule for that. What would be the product rule? It would be the derivative of x squared times the other function, and x tangent x, plus first functions times the derivative of the second one, sine x times tangent x derivative. Okay. I can calculate x squared derivative, simply 2x. This term does not have any derivative, so sine x tangent x is still there. Plus x squared times, what's the derivative of sine tangent? Now here, you have again 2 functions multiplied by each other and you want to find the derivative. Now you do the product rule again for this term. So what would be the product rule here? Use a bracket. Derivative of the first one, sine x derivative times tangent, plus the first function times the derivative of the second one, tangent x derivative. If you had 4 functions, you would process this maybe 3 times, depending on how you pick the function. But it's always product rule. You can never simply take the derivative of product. You have to always use the product rule. Okay, this first part stays the same. This is still the same. That stays the same, whatever it was. Plus x squared times derivative of sine is cosine x times tangent x, plus sine x times derivative of tangent secant squared x. It's good for me to show up to this step, since there is no more derivative, there is no prime sign left, everything is taken care of. So this would be enough. But if you want to simplify, you should be able to multiply terms and cancel out if possible. In this case, you might be able to, actually I don't see any cancellation, so maybe this is good enough. Yeah, I don't see any cancellation. So this is good enough, but you can distribute this x squared, and you can write tangent in terms of sine over cosine, secant in terms of 1 over cosine squared as well. 2 common denominator if you prefer, but that's good enough for me. Okay, so these are derivatives using sine and cosine, but here we didn't talk about the tangent line. How about the tangent line? Find the equation of a tangent line to this curve, y equal to sine squared x at x equal to pi over 4. Sine squared x is the same as, again, sine x squared. That's the same thing. Sine squared x is the same as sine x squared. Okay, so how do we find the equation of the tangent line? First, you need to find out the slope. So what is the slope? Let me write this. Slope of tangent line at what point you want it at x equal to pi over 4. What does that mean? If you want to find the slope of tangent line at pi over 4, that means find the derivative, replace pi over 4 in it. That would be the slope. So what we need first is find out what is the derivative function, f prime x. And you have sine x squared. What is sine x squared? Sine x squared means sine x times sine x. So take the derivative of that. What would be the derivative? Use product rule. You'll get sine x derivative times the other function. Derivative of the first times the second, plus the first function times the derivative of the second one. You see that it's the same thing. Sine x derivative is cosine x times sine x, plus sine x times derivative of sine again, cosine x. What you have is sine x cosine x twice. So you can write it as 2 sine x cosine x. Okay, so this is the derivative function. So how do we find the slope? We replace pi over 4 in it. So you get 2 times sine pi over 4 times cosine pi over 4. Sine and cosine pi over 4, they are both square root of 2 over 2. So 2 times square root of 2 over 2 times square root of 2 over 2. You can use the calculator or unit circle. Unit circle is a better choice. Root 2 times root 2 is root 4, which is simply 2. 2 times 2 would be 4. The denominator is 2 times 2 as well. So you'll get 4 over 4, simply 1. So we found out that the slope is 1. How about the point? The point is given, x is given pi over 4. So you have the x value. How about the y value? For the y value, you should replace, the y value comes from the original function. So y would be replace pi over 4 into the function, square it. So sine pi over 4 is square root of 2. So this is square root of 2 over 2 squared, which is simply 1/2. So now what you have is a point and a slope. find the equation of a line passing through that. It would be y minus y1, which is 1/2, equals slope 1 times x minus pi/4. This would be the equation of the tangent line passing through the point pi/4. Every time you want to write the equation of a line, what you need is a slope and a point. The y value always comes from the original function. The slope always comes from the first derivative. So it's important to find the derivative function first and replace the value given to find the slope at that point. Okay, before I stop this section's topic, there are a couple of examples about the limit of the identity that we learned. You can generate certain questions, something like these limits. So the identity that I mentioned at the beginning was limit sine x divided by x as x approaches to 0 is equal to 1. Right? And there was an outcome of this identity. I forgot to mention it. That was if you have cosine x minus 1 divided by x. This was the other term. This limit was 0. Remember, you multiplied by cosine h plus 1 divided by cosine h plus 1. And we got this identity that this term actually is 0. This limit would be 0. So if you see one of these two, or any form of it, you can use these identities. So for example, if you're given limit sine 5x divided by 3x, and they ask you to calculate this limit, you cannot cancel out the x's. Don't do that. What you can do is you can use this identity and say, what if this was limit sine 5x divided by 5x? If this was the case, simply you could compare it here. It's exactly the same thing. Instead of x, we have 5x. This would be simply 1. So since I do not have the 5x and I have 3x, what I can do is I can write it this way. Instead of the 5x, this was 3x. I can multiply a 5x and divide by a 5x. Why do I do this? So I can rearrange it. If I do this, I can write it as limit sine 5x divided by 5x times 5x divided by 3x. You see this rearrangement? I just interchanged the position of these two. I cannot only multiply the numerator by 5x. Whatever I do in the numerator, I should do exactly the same in the denominator. X approaches to 0. So now, by doing this, what do I see is exactly the same terms. Sine 5x divided by 5x. As limit approaches to 0, this term is simply 1. This is simply 1. And here now I can cancel out the x's. So what do I have is 1 times 5/3, simply 5/. The shortcut, yes, is to assume that it's 5/3 just based on the coefficient, but it's not a good way, not always correct. So stick with this idea that you want to create a similar term in the numerator and denominator. Okay. How about if we have tangent 6x divided by sine 2x? Again, do not cancel out these two. That's not correct. What you can do is rewrite tangent and say this is limit x approaches to 0. Instead of tangent, I'm going to write sine 6x divided by cosine 6x. This is the same as tangent 6x. Divided by sine 2x is still there. Okay. What can I do with the numerator to simplify? The only identity that I know is